Okay, let's go back into the Common Core Standard. So it's the same one. It is the A for algebra, polynomial roots, 3. So we're going to go back Common Core Standard. You know, of course, I do this for me, and you get the benefit of it. AAPR3. Identify zeros of polynomials. All right. So let's look at the first example. Find the zeros. Well, it says that we can factor it. So by factoring. Now, granted, you guys have taught you a lot of ways to do these. Calculator, poly button, graphing it. But on your next quiz, if it says factoring, I want you to factor it. You're going to get credit for the factoring and for the answer, right? If you can't factor it, you're not going to get credit for that piece. So how does this factor? Well, whenever you see four terms, and if it's a cubic, you're going to do it by grouping. Okay, what do I mean grouping? Check it out. By grouping, what I'm going to do is put the first two together and the second two together, okay? So I'm going to do this one by grouping. So if I take a look at the first two terms, the x cubed minus 3x squared, I'm going to common factor the first group, okay? So what do the first two have in common? X squared. So we take out the x squared and let's see what happens. What I'm going to have left is an x minus 3, okay? Now, I do want you to do it by factoring. So as far as an x minus 3, they really don't have anything in common, but you have to factor. They don't have anything in common. Well, they do have something in common. Just a 1. How's that going to help me? Well, if I say, well, they don't have anything in common, but they really kind of have a 1 in common, I go, okay, plus a 1, and I'd have an x minus 3. All right? Because I need to factor it. So by grouping, if I look at x minus 3, well, there's nothing they have in common, but, in a sense, they really do. They have a 1 in common. Okay? Now, if I take a look at what I have between the two factored groups, they actually have something in common also, don't they? The two factored groups have a x minus 3 in common, don't they? So I can common factor out that. Now I'm only going to write it once because it's going to represent it twice, okay? Think about this. If I have an AB plus a C on the side, and if I take out an A, I represent the A, I write the A once. You okay with that? See, I took out the A, took it out once. This one A, you said, but Mr. Davies, there's two A's up there. Yeah, but if I factor it out, it's going to be able to distribute back in. So when I take out the A minus 3, I write it down once, because what's left over is the x squared plus 1, okay? Does that make sense, how I common factored out the x minus 3? Now, we want to find the zeros, so let's set it equal to 0, okay? Now, x squared plus 1, I'd like to factor that again, but I can't. It will not factor. It won't factor, but we can solve it. So, okay, all right, 0 equals x minus 3. 0 equals x squared plus 1, right? Quinn's barely awake. We're going to hang in there, Quinn. Plus 3. One answer is x equals 3. Okay? That's easy. Second one, all right? How many answers?
2.
2. We've got to have 2 answers, right? Bring over the negative 1, right? Square root. When I square it, I got a plus or minus the square root of negative 1. Equals x. And then, well, gosh, that looks like I, doesn't it? Isn't the square root of negative 1 equal to I? So I'm going to have plus or minus I. There are 3 answers. And then I knew there had to be 3 answers because it was a cubic. So I have one answer is 3, and then I have the other 2, which is plus or minus I. Now, how does that work? If I were to take I and plug it into here, I'm going to show this to you, okay, real quickly, because I'm saying it's a 0, okay? And lo and behold, you really have an I button on your calculator. You really do. It's way down here. Do you see a little I button down here? So let me just, for fun, throw in the I. Let's go and take I cubed, okay? I'm telling you, I promise that this is going to give me an answer of 0, okay? Subtract 3 times I squared. And I'm going to go then plus I subtract 3. Boom, 0. Okay? Isn't that weird? Yeah, so it's got to be a 0, right? So the definition of a 0 is any value that makes the polynomial equal 0. Is this an x-intercept? No, this is not an x-intercept. No, 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 no. It's imaginary. It can't be an x-intercept. It doesn't even exist, does it? But it is a 0 because it makes the polynomial 0 when you plug it in. See the difference? It is not real. Negative I and I are not real, but they are zeros because they will make the polynomial 0, okay? All right. Example 2, double roots. Let's see if we can find a double root. Okay, so by factoring, let's see. Oh boy, let's see. If I have to factor this, first of all, they might have a... Yeah, they got an x. I think they got a 3 in common too. I think they've got a 3 and an x in common, okay? Guys, you okay with the 3 and the x in common? So I'm going to common factor first. And then I'd be left with an x to the 4th plus an 8x squared plus a 16, okay? So this factor, so I have to factor. I'm looking for 0, so I set it equal to 0, okay? Now, one answer is really pretty easy. This one's pretty easy. I've got 0 equals 3x, okay? Let's do the easy one first, and we'll go back to this one, okay? And so, divide by 3, right, Quinn? Divide by 3, and x is equal to 0, okay? There's one answer. Now, here I should get 4 more. I need 4 more zeros, right? I need 4 more because it's next to 4. So what do? I've got 0 equals x to the 4th plus 8x squared plus 16, okay? Okay, here's the trick question. I know how to do this. Does anybody out there know how to factor this?
You can't.
Anybody have any ideas? Ryan, do you have an idea? Let me hear what you got.
You could do like 2 parentheses.
Yep, I like that. That's what I would do too.
And then you can do x squared plus or minus 4x squared plus or minus 4.
Nice. X squared. You guys okay with x squared? I'm going to go plus 4 though, Ryan.
For simplicity's sake.
They're both going to be plus, okay? So I'm going to go plus 4 plus 4. How does, well, what in the heck? Well, x to the 4th, you see it? Do you see a 4x squared? Do you see a 4x squared? Another 4x squared. That makes 8x squared, right? And 16. Okay. All right. So then, this won't factor, but let's go 0 equals x squared plus 4. Nice job, Ryan, by the way. 0 equals x squared plus 4. Now we're going to get the same answers twice. That's what happens when you kind of get double roots, right? Minus the 4, right? Over here, minus the 4. We're going to get the same answer, but I'm just going to solve them anyway because I need 4 answers, right? Square root plus or minus the square root of negative 4 is equal to x, and same thing here. Square root it, right? So I get plus or minus the square root of negative 4 equals x, okay? Or plus or minus 2i, and that is 2 answers. There's a 2i and there's a negative 2i. That is 2 answers. I've got a 2i and I have a negative 2i, and over here the same thing, plus minus 2i. So my double roots, I get a double root. I'll say that again, I have a double root. I get a 2i, and I have a negative 2i. I have a double root. Okay, ready to turn the page? How's your head doing? Is this hurting your head? Good. Like that answer. Okay, now, a polynomial has zeros of 1/2 and 3 plus I, okay? So first of all, if it has a 3 plus I, it also has a 3 minus I, because they come in pairs. Remember we did that? We talked about that in our reading. Hey, if you get a 3 plus I, it's got to have its buddy, 3 minus I. They come in pairs, all right? So what I have is 3. So I know that my answer is going to be a cubic, okay? I know for sure this answer is going to be some cubic. So let's put it back together. So we have, if I had an answer of 1/2, okay? Are we looking? I'm going to flip the page. If I had an answer of 1/2, it would have come from factoring, right? So let's put the 1/2 back into a factored form. So I could have an x minus a 1/2, okay? That would give me an answer of 1/2. Everybody agree with that? Or 2x minus 1 looks better, looks nicer. You okay on what I did there? Wouldn't that give you an answer 1/2?
Yes.
Okay, good. Now, I also have this x minus a 3 plus I, and I have an x minus a 3 minus I. Oh, that just looks ugly. Good thing I know a trick. I'm going to teach you something. This particular book doesn't show this trick, but I do. Here is this cool little formula, okay? Now you could simplify this and work on it, and you can get an answer, okay? But I'm going to show you a little trick I know, okay? So, what I'm going to do is if you have imaginary roots, they come in pairs, we can use this little formula here. So I'm going to go, instead of this, I'm going to go x squared minus the sum. The sum of the roots. Sum, what does that mean? So the sum of the roots. So I have a 3 plus I and a 3 minus I, okay? Okay, so what does that sum mean? So this little formula says x squared minus the sum of the roots. So I took my 3 plus I and my 3 minus I, and sum means to add them together, doesn't it? So if I add these together, what do I get?
3.
6? You guys okay with 6? 3 plus 3 is 6, and these cancel, right? 6. So I'd go minus a 6x. And this says plus the product. So what do you think, how did we figure out what the product is? Yeah, let's multiply our 3 plus I and our 3 minus I. And we multiply. 3 times 3 is 9. Minus a 3i. Plus a 3i. Minus an I squared. Am I going too fast? Okay, I'll slow down for a second. So I just multiplied 3 times 3. 3 times negative I times 3. And I times negative I. These two cancel, right? 3i, negative 3i. Of a 9 minus a negative 1, right? Negative 1 from the I squared is negative 1, which makes 10. Okay? So, this piece, x minus 3 plus I, x minus 3 minus I, would simplify to this. It would. Trust me, it will. It will simplify to this. But this is such an easier way to do it, isn't it? Okay. If you were to use the quadratic formula, work this out, you would, or solve this, you'd get 1/2. You agree with 1/2, right? There's my 0. And if you were to do the quadratic formula on this, remember how you did it yesterday? You would get 3 plus I and 3 minus I, okay? So these are the roots. So we'll say that's equal to p of x, because that's my polynomial, okay? All right, homework. It's not that many. 1, 2, 3, 4, 5, 6, 7 problems. Let me go ahead and stop the recording, and we'll do our homework.